Got to give the people what they want. All right, you guys, let's get right to it. We got some types of numbers, simplifying square roots, and the number I. So we're going to talk about a lot of that today. A lot of this stuff is going to be relatively new for you, so some vocabulary that you got to get down. First, we're going to start off with 4 types of numbers that you should know. All right, so the first ones are real rational numbers. Okay, so real rational numbers, those are all the numbers that we typically use in our everyday math life, like positives, negatives, decimals that stop, fractions, etc. All right, all of these numbers can be written as a fraction, as a ratio. Okay, so for example, you get like -2, 2/3, 0.678. It's a terminating decimal. 5, the square root of 4, which is equal to 2. All of these are real rational numbers, and that's where we spend 95% of our time, if not more than that. Okay? So that's the first type of number. Second type of numbers are real irrational numbers. These are basically fall in 2 categories. These are like your non-perfect square roots. So square roots that you can't find a nice pretty square root to, and decimals that don't terminate, those decimals that keep going on forever. These 2 types of numbers cannot be written as a fraction, all right? So an example of this would be like the square root of 3. There is no pretty square root of 3. You put that in a calculator, you're going to get some kind of long ongoing decimal. Pi is another good example of an irrational number. It keeps going on forever. The number 3.151592 blah 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 blah. That would be an irrational number because it's a decimal that continues on and it has no like pattern of repeating. Okay? Ooh, I'm going to add this one to it. You should put this. Also, decimals that repeat. So 0.6 repeating. If it has a repeating sign, it's also real and rational. Okay? Then we have something all new, which I'm pretty sure should be new to all of you. And this is called your imaginary numbers. Imaginary numbers come from basically when you're trying to take a square root of a negative number. These imaginary numbers work in the unit called I. Okay, so that's something new. I is an imaginary number, and I represents the square root of -1, and you're going to see this later on in this video. And we know this is impossible with regular numbers because no number times itself can be negative. So there's no way, like 1 times 1 isn't -1. And -1 times -1 isn't -1. So that's why we have this imaginary number I, which represents the square root of -1. So an example of an imaginary number would be the square root of -8, or I, or the square root of -16. These are all imaginary numbers. Then, finally, we get down to complex numbers. And these will actually you be using a lot moving forward in this little part. So these complex numbers are a combination of real and imaginary numbers. I actually don't think that this would be it. But so 4i would be a complex number. 3i root 2 would be a complex number because we have a real number and we have an imaginary number. So they're like these complex numbers are combinations of both real and imaginary numbers. Okay? That is what you need to know there. Make sure you have all that down in your notes. We got one more thing. So now we're talking about simplifying square roots. And we did this in algebra. It was kind of a bit thing, so you should be able to pick this one up pretty quickly. And it's not too complicated. It shouldn't be for you guys. Okay, so you can simplify a square root if you can find a perfect square as a factor inside of that root. All right? So over here, I wrote down a lot of common perfect squares for you guys. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those numbers are what you're looking for as factors inside your roots. So for example, when you have 18 here, I can find one of these perfect squares, 9, as a factor of 18, because 9 times 2 is 18. So it's like the square root of 9 times 2, which I could break into square root of 9 times square root of 2. Square root of 9 becomes 3, and the square root of 2 is just 2. Same with 32. I could find a perfect square inside of that. 16. 16 is a perfect square, and it's also a factor of 32. So I get the square root of 16 times the square root of 2. 4 is the square root of 16, and the square root of 2 I can't do anything with. One more example, 24. I can find a perfect square inside of there, which is 4. 6 times 4 is 24, so it's the square root of 4 times the square root of 6. 2 is the square root of 4. And you're left with the square root of 6, okay? So this is how you simplify square roots. And finally, getting back to those I and those imaginary numbers, let us simplify some negative square roots. So you can simplify a negative square root by using the number I, which stands for the square root of negative 1. So remember that I equals the square root of negative 1. So for example, the square root of negative 81. We know good and well that we can't do that because 9 times 9 is not negative 81. And negative times 9 times negative 9 is not negative 81. So I break it down. I get negative 1 times 81, which just like we did up on top, I could break into the square root of negative 1 times the square root of 81. 9 is the square root of 81, and the square root of negative 1 is I. So this final answer is 9I. Square root of negative 18. I could even do some more work with this one, similar to what we were doing up top over here, right? So I know I got to do a negative, so I got a negative 1. But then 18, I could find a perfect square factor, so that's the square. That's 9 times 2, 9 being my perfect square. So I have the square root of negative 1, square root of 9, the square root of 2. Here's your square root of 9. I is connected to the square root of negative 1, and the square root of 2, nothing happens right there. But notice how I write it. I write 3i root 2. That's how that ends up. That's the proper format. You know how I know? Because I looked it up on the internet. Yeah. Finally, square root of negative 100. This one's nice and pretty. Negative 1 times 100 is 100. So that's the square root of negative 1 times the square root of 100. 10 is the square root of 100, and I is represented by the square root of negative 1. So there you have it. These are just some skills that we needed to get out. Didn't want to spend a really long time in class going through all of this, so make sure you have all the notes down. You're ready in class. Also, you guys have this test coming up on Wednesday, and I'm going to be posting these other videos for review. You should probably review them. That'd be a good idea. All right, you guys. Do your work. Do it the right way. Have a great day.